Hello, everyone, and welcome to another episode of the Show About Science. This is your host, Nate, and today we are going to be swinging through the branches of the world of tails. Ever wondered why you don't have a tail? Well, today we are going to find out. Stay tuned because it's going to be a wild journey through the tales of time. Alright, so first of all, welcome to the show.
Thank you. I'm glad to be here.
Yeah, you're welcome. And so, can you tell our listeners a little bit about yourself?
Sure, I'm Bo. I grew up in China and then I went to Beijing for my undergraduate studies. And in that time, I developed a strong interest in biology and chemistry and the molecular basis of living beings. So I want to do research in this field. And I'm about to graduate, still a graduate student here at the New York University School of Medicine. And I'm glad to be here to introduce my most recent research.
Alright, Bo, I am very excited to talk to you about all the research that you've been working on at the New York University School of Medicine. Whew, that's a mouthful. And that research is all about tails and human evolution. So, tell us a little bit about, why don't humans have tails anymore?
That's a very interesting question because I thought about this question when I was a little kid, and of course, at that time, there was no answer to it. So we don't have a tail, but we have a rudimentary tail inside our body, which is just like 3 or 4 vertebrae, which extends from our spine and didn't extend to the external of our body. So it forms our tailbone. So when we are talking about why, there is evolutionary answer to it and also developmental answer to it. So from a simple side, developmental side, we have this program because in the evolutionary biology, the monkeys have the tail, which we share the same ancestral species. So there must be some kinds of molecular program that could enable us to develop a tail. But somehow this program was disrupted. And when I'm talking about the evolutionary reason, that's like how this happened during development. So during evolution, there's something that prevents our tail from extending to an external tail. So just leaving the so-called tailbone in our body right now.
So, let me get this straight. We do have this thing, a tailbone that should be growing into our tail, but at some point way back in our evolutionary history, there's this mutation that happened, and that blocked our tail from becoming an actual tail outside of our bodies.
Yeah.
So, why do you think this mutation happened? Why do we just have a tailbone and no tail?
Yeah, when we are talking about why some kinds of mutation happened, I have to be honest, it's a very challenging question. On the other hand, it could be very simple because it could be a random event. And that's because in biology or in genetics, there's a lot of randomness in mutations. For example, on average, every child has around 10 to 100, this kind of range, mutations different from their parents. We all say we got the DNA from our parents, but still there's some minor changes when we compare our genome to our parents' genome. In most cases, these mutations does not matter, but in some cases, this mutation could do something, and then natural selection will select for the ones who has a mutation that helps them to survive best. So when we're talking about why some kinds of specific mutation occurred, in many cases, the best guess is it's a random event, and then a specific mutation is doing something good in a specific environment, then this mutation will be selected and enriched, which becomes the dominant in a specific environment.
That's interesting.
Mhm.
So, why do you think that the mutation just got rid of our tails and not our tailbone?
So you're asking me very tough questions and very interesting questions. I never thought about it because we leave 3 to 4 vertebrates and the very posterior part of the body. We call it caudal vertebra, and they will fuse together during human development and becomes a so-called tailbone.
Hmm.
Instead of like other species, for example, monkeys, their caudal vertebra can extend and have a external tail.
I see. So, the caudal vertebrae are the bones that make up the tails. In humans, there's a few that join together to make up the tailbone, but in animals, like monkeys, there's a bunch that become the tail.
Hmm.
Alright, got it.
Yeah. So there must be some kinds of like very clear genetic regulation that make us have very homogeneous phenotype, leaving 3 to 4 vertebrae. So I would say the short answer is I don't know exactly on this, but natural selection seems to favor a no external tail phenotype. So this genetic mechanism will act together in a complex way to keep only the 3 to 4 vertebrae which may have a selective advantage, presumably affecting the locomotion style, that selects for this phenotype. So, short answer, I don't know, and but I believe we can figure out because of a few decades of research in developmental biology. Yeah.
So, like, what is the anatomy of a tail?
In most cases, the major part is the tail vertebra or caudal vertebra. So it's an extension of our spine, and different species may have like different numbers of vertebra. It could be as long as like 20 vertebrae or just a few less than 10. And then some species have like stronger muscle attached to this vertebra and of course to the sacral part of the body, which helps moving the tail. And then outside is just the skin. So it's a relatively simple anatomy.
So, when does the mutation that blocks tail growth take place in our evolutionary history?
So first, we have to be clear, this is not a human-specific trait. As we described in the paper, apes, chimps, gorilla, gibbon, they all share the same no-tail phenotype. So this is a trait shared by, in a short word, homoloids. So because of the past 2 decades of efforts sequencing the genomes of all these homoloid species, we know the sequence of all these genomes. And then we can use a mathematical way to calculate when the mutation happened. So based on these efforts, we can find the specific genetic change that's happened to the humans and apes and compare them to the more ancestral DNA sequences, including those monkeys. So we can infer this timing being around 20 to 25 million years ago. That's when this mutation happened. In a simpler way, this mutation is shared between all the apes, but not in the monkeys. So this event is happening when the ancestral apes diverged from the ancestral monkeys around 20 to 25 million years ago.
I see. So, what kind of tails did humans used to have? And what was their purpose?
You mean ancestral human or
Yeah, like, why did humans used to need tails?
I would say in a more accurate way, like let's say the ancestral monkey or hominoid, because when we are defining human, it only happened around 3 to 4 million years ago. So that's way after we lost our tail. Obviously, a good way to detect the tail of an ancestral hominoid or ancestral monkey is to use a time machine, but obviously we don't have it.
So, what purpose was there for tails?
You mean for human or for other
Yes,
species?
for humans.
So there are various different functions of a tail that we can infer from existing hominoid species. So a tail could be short and kind of long-functional, or tails could help to keep balance on the branches. They kind of use their tail as an extra limb, so they can use the tail to hang the whole body on the branches to help them live on the tree. So there are various different functions of a tail that we can infer from the existing species. So that's how we guess the function of a tail.
So, hypothetically speaking, if a modern day human were to still develop a tail, what use could there be for it?
Are you talking about like in a sci-fi way, like let's say if a modern human, like still develop a tail, like how we could take use of it, or
Yeah.
That's an interesting way to think about it, because I'm not sure if you watch a movie called Avatar by James Cameron.
Not yet, but the language I have heard is very in-depth.
So in that movie, they have a species called a kind of people, the Lavi people on Pandora, and they use a tail to communicate. Of course, it's like way beyond the tails on Earth. For example, a dog like wagging the tail is a way for dogs to communicate. So if we imagine, like, let's say the modern human has a tail behind our body, it may affect our body balance. On the other hand, I would imagine it probably a way for us to communicate, like when we use hands to help us communicate. We have hand gestures to help us communicate or talk to different people. We may have different postures with our tail, and I guess when we are happy or sad or feel worried or concerned, our tail may have different postures, I would say. That's an interesting way to think about it.
Well, the posture of my hypothetical tail right now is sticking straight up because I am very happy with the way this interview has turned out. So, thank you so much, Bo, for coming on the show.
Thank you, Late, for inviting me here, and have a great weekend.
Yeah, no problem. There you have it, folks. The show about science is complete. Our theme song was composed by Jeff Dan and Teresa Brooks. And remember to subscribe and leave a review wherever you listen to podcasts. All right, Dad, you can shut the recording off.